The Adventures of Ed Leedskalnin. Hello, this is Roy back again. I have to do this video. I had such great results with this that I'm just going to give you a little tidbit thanks to my boy. So these here are pretty much, I mean, I can pull them off, but it takes a lot of pulling to pull these off. And they're stuck there for one reason and one reason only. I decided I have two pipes and I have two grounding systems that are electrostatic plates. I guess I'll have to post a video on how I done those and put them in the ground. And there's two electrostatic plates on top as well. One on the inside of the glass, and you'll see the glass has points on it. So you have a capacitor, a thin capacitor on the inside. And you have a conductor on the inside, a thin plastic dielectric. Then you have another conductor plate and then the glass on the outside. The key on the glass on the outside is very important versus on Tesla, you have a conductor to make the whole thing as a dielectric. So what I did was I have on top here two setups. And on the bottom of the pipe, I have a 1 foot square box set up similar to the top, to where in the ground, okay? Except for the glass is not in the ground because the ground is the glass, because the ground has a large amount of silicone in it. I'm in Florida, and just it's a dielectric, it's a crystal. So I have just a thin plastic layer around a hole that I made, the bottom of the pipe. Now the pipe is not connected to this apparatus at the bottom. It's isolated, insulated as well. And so that makes the top and the bottom kind of its own thing. But I haven't done this yet, but I'm getting ready to put a coil down in the middle of the pipe so that becomes a satchable reactor between AC and DC. And we'll get into what I'm talking about with that. But what I did was I fired up the Tesla coil just with 12 volts, okay, and used a 2N3055. And sparks came out of the top there and went to the glass. And when it went to the glass, it somehow made its way through the circuit, inductively through. And what I noticed was the wheel picked up in speed. And what I did was I went and got these laminated pieces I had from the mods I took apart. And the more the laminations, the thicker, like pulling this off, I could pull it off. But it took a lot to get it off. I mean, it's got Superman strength. So it came in from the ground. I'm taking electrostatic. I said, let me use some of my Tesla experience here and introduce it to this apparatus. So here we go. Leave your comments. This is the next important thing we're going to do on another video. That metal pipe looks like an antenna. Look how tall it is. And at the bottom, it's got a circle where it was hanging. So if you go over here, and if you look at the top, what do you guys see? What do you see? That bar goes across. Don't tell nobody. That bar goes across. Look at the Y on top. Look at the Y. Just giving out one of the Ed Leedskalnin secrets that not even my buddy Poole or Ed or Scott from Made by One Man know about. We're gonna build one of these, and you're gonna see that's an antenna. That is going across right there. Look at it. It's right there. Why is that there? Let's get into it. Electrostatics. Bringing some Tesla. Think about this. Tesla was involved. He read about Tesla. He had to. It's all about Tesla, especially in 1917. He had this wheel really early because whatever the date is he got his first property, he had this wheel then. He started carbon right away. And that's what he did. That's where I'm going to give a shout out to my buddy, Made by One Man, Scott Russell, because it had 10 different wheels, and this is his best, 10 different machines, and this is his best machine. So we're getting to the best machine. Another thing, one of my subscribers asked how much torque it has. And I started thinking, wow, the best of the best torque electric motors I could come across is a washing machine motor. It's 3-phase. And Ed says in magnetic current, my best machine, he says, what if you had a wheel with coils all around the wheel turning? You would have all kinds of light. And what he meant is that you could 3-phase this all the way around. So the torque on this is so intense that no matter what you put in front of it for a pickup, because he says, my best machine is a combination of field magnets or field coils and coils. So he's calling field coils these things, I believe. I don't know. You got coils here and coils there. He also talks about the windings on his best machine, not like the windings on my best machine. And he says that. So here's the winding. So I got on here. So this is what I'm getting ready to do. You guys are going to like this. On here I have over 10 pounds of 16 gauge wire. And I think I was too short, so I had to add a little bit more. There's 66 turns on each one, so I had to add 122 feet of wire. I'm going to go ahead and build PMHs to go all the way around. So if you see the way I have it set up right here, you can see that they're set in quadrants, I'm going to call these, segments. And the segments are little PMHs. And these guys are unbelievable. I mean, the interesting thing is, when you charge these, you could put a light off the ends here and it lights up really good. And I use that as a charging system. All I do is touch these two ends. As long as I have a light bulb here, it'll draw through the whole system and charge these. But now I found another way to charge them. Now I just set off electrostatics in the Tesla coil. It regulates. Now here's the key, guys. This is going to be the cool thing. It's going to regulate the oscillatory satchable reactors, which will be tied to the Schumann resonance in the ground. So the casing of the pipe goes on the outside layer of the capacitance, or should I say electrostatic plates, which is capacitance, in the middle. And like Ed says, if you want your best pulling strength, you would encase that coil into a metal casing and touch one end. So basically in the ground here, I'm creating superconductors to the ground. Leave your comments. Superconductors. Leave your comments. Superconductors, very important. Tesla was using liquid, I think nitrogen, just to chill down the pipes in the ground so they would be better conductors, as he did his Wardenclyffe experiment. I have a lot of Tesla experiments now underneath my belt, so this is holy grail, because now we're mixing the electrostatic, because electrostatic can come from just turning the wheel into anything in a capacitor becomes electrostatic, but more so when it's high pressure. So that means you need high voltage. In order to have high voltage, you got to step it up. So here's where Tesla comes in. So I can create an oscillatory system just from the Tesla coil going off. Now it's going to react and come off into the glass domes, which are going to charge up the capacitor plates at the top. Therefore, they'll come to an oscillatory system with themselves from what's in the ground. So the ground, the top, starts oscillating. When the ground is oscillating, it's like having two probes in the ground, and each one is going to be fully pressurized and then released, bam, like an event, bam. And these two will be out of phase. So when one's going off, the other one's receding and charging. When the other one's receding and charging, the other one's going off. So it's kind of oscillatory there. And then on the top, it's doing the same thing, because you have the Tesla coil in between the front run of everything now. Here we go, guys. Beautiful. You kidding me? And the strength of these are all charged just from me firing up the Tesla coil. So as soon as I fired up the Tesla coil and started turning the wheel, all of a sudden I was like, okay, well, speed's kicking in a little bit more. And I realized one major thing is that this beautiful device is just me learning like Ed, okay? And obviously we're not in Ed's time. So this thing will not be what we're going to use, but at least showed us that we can turn the wheel. We can do things around it. But now it's going to go into this. We're going to take this gear down here. I just ordered a gear and a shaft from a starter, and this is a starter. These two top and bottom gear rings are from the flywheel of the Model T Ford, so they're starter gears. So we're going to gear off of that, and I'm going to create a lobe on the shaft that's going to get back off my knees. That's going to yeah, gonna do something, huh? Ain't that something? Well, when in doubt, go to the ground, right? So, those lobes are going to open and close these points. Got a condenser on it. I know Ed used Model T parts. You know what? They're so outdated that we're going to step it up into today's. This is a nice set of points, I think, off a Chevy Nova. So this here will go mounted down bottom off the shaft, and I will figure out the 24 how many teeth are on here. Like there's a lot of teeth, right? Look at that, a lot of teeth, and it'll be precise. What I realized doing my last video, if you guys look at it, I'm at the maximum speed that the relay can go electromagnetically. And then from there, it just no longer works. And I had to go just to give it a little bit tug, and I realized that. But I accomplished up to that level, and I think that I got to give out a coots out just for that achievement. Just the fact that I got to the speed. So now it's time to take it further. And what came to my mind was, if I was in the Model T and giving it gas, everything was mechanically controlled. Variances everywhere, but mechanically controlled. So that's where I said the gear. And if you look at the bottom of Ed's wheel in my old videos, he has a gear down there. So he had a gear to run off of. So I'll figure out the ratio from this. 24 magnets. I got these segmented, so each one is like a PMH. And that's the way we're going to create this whole mechanism, when it's turning, it's going to get the system running, and the system will turn to Schumann resonance, and that'll be somewhere between 7.8 to 20.2 hertz, and somewhere in there, in that variance, we're going to let the electrostatic plates down bottom tie into a certain angle of the Schumann waves. So once you get into that angle, it should tap into the angle, and all of a sudden here I should be blowing off the top of these glass bulbs because I dialed it in. So you guys, leave your comments. Peace out. Love y'all.